Data consists of the raw facts. For example, data is generally what we enter into the computer as input. Information is the processed data, for example, the output of a computer program. Knowledge helps us to understand the information. If you are interested to learn more about data, data management provides an opportunity to learn and implement the best practices of generating, storing, accessing, sharing, and protecting data. For example, a data breach is an unauthorized access and sharing of data, generally personal data. A database is an integrated computer system that manages data. A database management system is a set of processes that manage and control access to data stored in a database. Data sharing allows users to access and manage data. For example, at our institution, we use a database management system to manage student information, which makes it easier for the enrollment department to share students' data with the academic department to plan and create courses. Data security is critical to a database management system. Data security ensures that only authorized users access data. For example, when you log into your student accounts, you provide the username and the password. The institution now uses the authentication as another layer of security to protect students' data. Data integration allows the institution to see the big picture. If we take example to student data in our institution, data is collected from different departments such as enrollment, grades from different courses, financial aid department, academic integrity. At the end of a quarter, data is integrated together to generate a transcript and track the student progression towards graduation. Minimizing data inconsistency, DBMS sets rules for data formats to facilitate inserting, updating, and deleting data. DBMS sets rules to prevent data duplication. For example, it should not be possible to register students twice in the same course. For data access, DBMS allows users to access data using a set of questions, also called queries. For example, what is the student grade in a database management course? Another advantage for DBMS is also to make decisions. Information is generated for decision making. Quality data is key to decision making. That is why many institutions are investing into data analytics to ensure that policymakers and executives have quality data in making short and long-term plans. The last advantage is to increase end-user productivity. Data is available to end users to make decisions or to also support institutions. We can classify databases based on different factors. So we're going to classify databases based on users. We have a single user and multi-user database. So a single user database accommodates one user at a time. For example, if you are creating a database on your desktop computer and only one user can log in, you have a single user database. For multi-user databases, multiple users can access the database at the same time. A work group is regarded as a database with a limited number of users in a department, while an enterprise database provides access to many users across many departments. We can also classify databases based on location. We have a centralized database, distributed database, and a cloud database. If an institution has a database at a single site, this database is called a centralized database. Assume that our institution has only one database on one campus managing student data. This is an example of a centralized database. If an institution has databases at different sites, this type of database is called a distributed database. For example, a student database on 2 campuses. Finally, a cloud database uses cloud services. This means that institutions do not buy physical hardware for storing and managing data. A cloud service means a service that does not rely on physical storage. For example, Gmail accounts are stored in the cloud, and other examples are Google Drives and OneDrive. We can also classify database based on data. So we have structured, unstructured, and semi-structured database. In the next slides, you have the information from Amazon Web Services. So for semi-structured data, for semi-structured database data, semi-structured data combines the structured and unstructured data. In this class, we are going to focus on structured data, which are the data based on the numbers, short text, and dates. So for unstructured data, we have data that we cannot easily organize in a table. So for example, we have audio and video files. And semi-unstructured data, it's a combination of both types, structured and unstructured data. We're going also to see the basic terminologies. A database consists of tables, and the tables are also called the entities. A field is an attribute of a table or entity. So here I have one table, which is student table. And also I can say that I have an entity, like student is an entity. So a field is an attribute of a table or entity. In this table, I have 4 fields: student ID, first name, middle name, and last name. A record is a collection of items or a row in a table, which means that in this table I have 2 records. The first record for the student 0001, the second record for the student 0002. We also must ensure that we are following the same fields formats in entering data. For example, if we have 4 characters for student ID, all student IDs must have 4 characters. This is critical for the data entry users. You need to make sure that they are following the same format. For example, here we have 4 characters reserved for the student ID. So we should not have a student ID with 2 characters. This is also another example. For example, here we have how many records? 1, 2, 3, 4, 5, 6, 7. So we have 7 records. And each record has how many fields? So we have 1, 2, 3, 4, and 5. If I take an example of the first record, which is 21-5Z, so this record is composed of 5 fields: project manager, manager phone, manager address, then project bid price, which means this is the information on the second row, because the first row is for the field name. Then we need also to be consistent. So if here we have the format for the project code, so we have how many characters? 1, 2, 3, 4, 5. We should not enter the new project code as 22-M because this will generate inconsistency. Data redundancy generally means you have data duplication across locations. For example, student data is duplicated from different locations. Data duplication makes it harder or impossible to add new data, updating existing data, and deleting data. We refer the whole process as data anomalies because the data is not clear, so the data contains anomalies. It is understandable that data redundancy provides poor data security because copies of data is available in other places. Data redundancy also generates data inconsistency and data entry errors. Updating one copy does not necessarily means that data is updated in another copy. It's important to note that data redundancy affects data integration. Data redundancy generates anomalies, and we have 3 types of anomalies. We have update anomalies. Data exists in different copies, and updating data becomes a challenge. Insertion anomalies: due to copies, it is a challenge to add new data to a database. Deletion anomalies: deletion of data cannot be done in different copies. When you design a database, you must always think about 3 main operations: how to add a new record, how to update existing record, and how to delete existing record. The database system is composed of hardware, software, people, procedures, and data. Hardware refers to the physical devices such as computers, networks, and so on. Software is a set of programs such as operating systems, DBMS software, and application programs, including, for example, Microsoft Office package and antivirus. People includes all the users of the system, such as end users, administrators, and staff. Procedures are the instructions and rules that govern the design and use of the database system. For example, user access control. A faculty is not allowed to see a financial status of a student. Data, so the word data covers the collection of facts stored in the database. And here you have the visual representation of the 5 components of the database system. This slide shows different positions for a database professional career. Please take time to view the job title, description, and the skills required for different positions. There are also challenges of implementing or maintaining an updated databases system. The first disadvantage deals with the increased cost in hardware, software, hiring, and retaining qualified IT personnel. The second disadvantage deals with many technologies to implement and secure the database systems. Database systems may also change the institutional culture and require trainings. The third disadvantage is for the institution to keep the latest technologies and ensure that database systems are up to date. The fourth disadvantage is vendor dependence. For an institution that works with many vendors, it may hesitate to change the database system if the new system will affect data collected and shared with vendors. Finally, we have the issues with the frequency for performing upgrades and updates. If the DBMS vendors frequently upgrade their products by adding new functionality, it can prevent an institution to adapt the database systems. This is for the activities in this chapter. Each table must have a primary key that uniquely identifies each record in a table. For example, student ID. This is the student table. Student ID is the primary key for the student table. We know that two students cannot have the same student ID. In creating a table, we must ensure that all fields depend upon the primary key. If we are creating a table for a student, so here we have student ID, student name, advisor, advisor's office, dorm, and dorm address, we should not put fields related to advisors and dorms. Instead, we should have many tables and link them together through relationships, and we'll see that in the next chapters. This is also another example that you have here in this slide. For the table student below, student ID identifies each record. Even though a student must have an advisor, the information related to advisor must be in a separate table. In other words, advisor's information does not depend on primary key student ID. So in other words, if we want to register a student, we do not necessarily need information from advisor. Sometimes we needed to use dummy records as temporary placeholders, and we use dummies in case we do not want to lose data. So this is the student table. For example, if we want to delete student ID 45678, if we delete these students, we are also going to remove the information take measure from this table because there is no any other student, there are no other students with measuring in the same major information technology. So instead, we are going to create a dummy record, which means a dummy record may have like a 00s here, student name, fake dummy name. So then for us to be able to keep the information technology as a major. Most of the time, database managers must define dummies so that they can be deleted once real data becomes available. We are going also to use a dummy record if we want to add a new major. Let us say here we don't have English, then we wanted to add the major as English and we don't have a student majoring in English.